Today, we will discuss our lesson 2, which focuses on electrostatic force. And here are the following learning competencies for this lesson. First, we will be able to calculate the net electric force on a charge exerted by a system of point charges. When we say net electric force, it also refers to the net electrostatic force. And number 2, understand the process of charging on 2-point and 3-point charges. Before we proceed, let's recall the law of universal gravitation. I know that most of you are familiar with this topic because I know you had encountered this in your physics class. So the law of universal gravitation refers to the force of attraction between two heavenly bodies. Like, for example, we have here in the illustration, we have the Earth and the Moon. Okay, so the Earth and the Moon has so-called the force of attraction. And we call that force of attraction as Fg, or this refers to the gravitational force. Okay, if you can recall, here are the given. Like for example, if the mass of the moon is 7.4 times 10 to the 22 kilograms or raised to 22 kilograms, and the mass of the earth is 6.0 times 10 raised to 24 kilograms, and approximately the distance between them is 3.8 times 10 raised to 8 meters, and we have the gravitational constant or the universal gravitational constant, which is 6.7 times 10 raised to negative 11 Newton meters squared per kilogram squared. We can calculate for the force or for the gravitational force between the Earth and the Moon. And as we all know, this gravitational force is responsible for phenomena such as high tide and low tide. So when the moon is closer to the Earth, we call that the perigee, I guess. And if it is farther, we call that the apogee. Okay, so here is the similarities between Coulomb's law and the universal gravitation. They have the same forms, or they have the same, or the way the formulas are constructed is somehow similar. For the law of universal gravitation, we have here F. Most of the time, we refer that to Fg. Fg meaning gravitational force. This is equal to G m sub A times m sub B over R squared. The G here is the constant value, which is the G is our constant. And that is our gravitational constant. Okay, isla ko na lang sa gravitational constant. Okay. So, ang G naton, this is gravitational constant. And according sa previous slide ta kanina, that is 6.67 times 10 to negative 11 Newton meter squared per kilogram squared. So this is the G. And M here stands for the mass. Kay MA na diri class, sometimes it's M1 or whatever, basta mass na siya class ang object A. Or this is the mass of A. A could be anything, an object. In this case, MA could be a soccer ball or a moon or things like that. MB is the mass of B. So in the illustration, MB is the mass of the Earth. And R stands for the radius, or it refers to the distance. Most of the time, we refer it to radius because if we are going to picture out the law of universal gravitation, it is the moon that orbits the Earth, diba? So similarly, Earth is the center, and we have here the radius, which is also the distance between the Earth and the moon. So amo na siya nga radius. I think this is just a review na lang kay discussion naman inaa. And for example, if we are going to relate this with the Coulomb's law, they're very much similar. Tandaan lang, if we are dealing with the law of universal gravitation, we are looking at the heavenly bodies, meaning it's more massive. But if we are looking into if we are dealing with Coulomb's law or the electrostatic force, we are dealing with smaller, micro naman siyang level because we're dealing with electrons, atoms, and charges. Okay, so we have here, kung kagina, our constant value is is G. Here we have K. And letter K or small letter K, iba na book, capital letter K man. This is what we call the electrostatic constant. Okay, and that is 9 times 10 to the 9 Newton meter squared per coulomb squared. So if we are going to compare these constant values, the same sila nga may Newton meter squared. It's such that for the law of universal gravitation, we are referring to kilogram squared kay mass siya. But for the Coulomb's law, this is coulomb squared since coulomb is a unit for charges. So meaning ang Q na dira, QA na dira class is the charge. Refers to the charge of A or charge of any object A, and QB is the charge of B or any object representing B. In most cases, this QA and QB can be referred to a proton or a neutron, not necessarily neutron, kaya wala man charge ng neutron. So it could be a proton or an electron. And they have the same R. Ang R na diri refers to radius. Okay. And in addition, if for the law of universal gravitation, we use Fg, or we represent the gravitational force as Fg, for Coulomb's law or electrostatic force, we are representing F as Fe, meaning Fe for the electrostatic force. Okay, so here is a simple representation of electrostatic forces. In short, like charges repel and opposite charges attract. So these are basic concepts. So both positive and positive charges outward, kaya they are repulsive, or we call this force as repulsion. And for the opposite charges which attracts, it's either diri ang negative, o diri ang negative, or diri siya still attraction man na Japon, and the force is attraction. And this one is repulsion.